I am Piers, CEO of RDX Works, core developer of the decentralized finance protocol Radix, a public ledger entirely focused on bringing DeFi into the mainstream. This is our podcast, The DeFi Download, a show about decentralized finance and all things crypto, where we dive into the details of the projects, assets, and services that are powering the DeFi revolution. Today, I'm joined by Josh Tobkin, CEO of SupraOracles. SupraOracles are supercharging oracles for better, decentralized future by building better, faster, accurate, and more secure sources of off-chain data on-chain. Josh, thank you so much for coming on the show.
Yeah, great to be here.
So there's like some really interesting sort of like top of line information as to why oracles are such a big issue for public ledgers. And you know, recently we've seen quite a lot of exploits, right? I think something like 730 million due to exploits of oracles of various kinds. So that seems to be a sort of a big problem that the industry is facing. Now, you guys have come in a little later than sort of other people in the space. So why don't you just give me a little bit of background of how SupraOracles started and what you think that the gap that you saw is missing in the market and that drove you to build what you're building?
Yeah, certainly. So yes, I do understand that it may appear that we are kind of late to the game, but there's a couple advantages of coming in late, actually. We could analyze what has worked and what doesn't work, and we had the time to study other approaches and innovate. And also, by and large, I do want to mention that my belief is that this is still very early, that we're still in the first innings of this revolutionary technology. Blockchain, I do have a fundamental belief that it will have a huge impact in the world, and we're still just at the tip of it. So, but yeah, to answer your question, what kind of drove us into this? This was actually, I guess the roots are in 2017, actually in San Francisco, where kind of some early research was into. We were doing some research into blockchain. 2018, we set up a crypto lab, and during that period from 2018 crypto winter, right, it was a really tough period, 2018 till 2019, 2020. We did a lot of experimentation, from learning about other consensus protocols to actually implementing blockchain and solutions for different categories. And one of them was food supply chain. So I had a background in food supply chain and startups in the past, actually. And we were working with IoT devices and mapping it to blockchains, thinking through like, how do you create a IoT fault tolerant mesh network, all the way to securing that data from the kind of physical world through gateways into the cloud. Fast forward though, like this experience had, we through this, we had pilots with like companies, publicly traded companies like called Avantech in Taiwan, which is a publicly traded IoT and cloud provider, but they had no blockchain experience. We built out their middleware for them. And also this had led us to an opportunity to work with Walmart China to create a pilot in the food supply chain solution where we had IoT meets blockchain with QR codes, et cetera, to guarantee what they call the secure cold chain logistics solution. This is kind of the background of like, how do you get external data on chain in a secure manner? And then, of course, really to get to your answer or to your question it was in 2020 during DeFi summer, and we were seeing all these kind of Oracle exploits and manipulations. And we were like, oh, wow, we did a lot of research in consensus algorithms as well as getting external data on chain. We think we have a novel approach that is very secure, but also very fast, that we can bring a differentiated product to the world. So that was the root of SupraOracles.
Got it. Okay. So like, I mean, some people, listeners of this podcast are certainly going to be familiar with the early exploits of DeFi summer. Can you describe a couple of exploits that happened back then that would be solved by SupraOracles and how SupraOracles would solve that?
Certainly. So there's a couple of variety of different Oracle exploits. So let's talk about a basic one where a major DeFi protocol, they were getting their data from a major exchange. I don't need to mention the names. And they're getting, like, for example, the price of Bitcoin.
Oh, that's no fun.
I know. Well, one of these exchanges are actually investing in us, so I don't want to throw shade at them, but very reputable organization. And it was just, of course, this is a very early period for just the industry at large. So, everyone was experimenting. But their model was, and the DeFi protocol was getting the data from this exchange directly, relying on the fact that that exchange would cryptographically sign the information. And they thought that was enough, both the developers and the researchers on the DeFi side, and the exchange was just opening up the service. Now, the thing is, just because someone has cryptographically signed, for example, the price of Bitcoin, that actually doesn't mean that it is the correct price of Bitcoin. It just means that someone had access to the private key. And what happened was someone or something was signing incorrect data. So incorrect data got into a smart contract. That smart contract executed it, and it caused some problems. So this is an instance where it's a singular source of information, very reputable, nonetheless, a single point of failure, and someone somehow got access to the key and signed incorrect data, and that entered a blockchain. That's one instance. There's other instances where, and I don't want to mention Oracle names or project names either, but where like a small cluster of nodes from a very reputable or well-known Oracle, small cluster of nodes, they had signed off of information, and a DeFi project was getting that information from that Oracle, but they had screwed up their results. Basically, they had reported the wrong information, and they didn't have any repercussions. They didn't have any recourse or any remuneration at all. It was just like, oh, sorry, my bad. Shit happens. And it's like, really? There's really, what I'm saying is, like, if you have your securities bound to a small set of nodes that are not staked, that are not, they don't have this like economic possibility of penalty, and their identities are not necessarily known, then it's very easy for them to, be a little bit careless about their reporting. So in that case, your network security is bound to a small set of nodes. Now, another major kind of Oracle and bridge exploit that's become kind of common is this idea of flash loans. So now that is using on-chain data to protocols that were using on-chain data to use what's called a constant function market maker. So like, X times Y equals K. Formula, which is a algorithmic estimation of what is the price of X, Y, and Z. Those types of systems rely on arbitragers to get back to an equilibrium. And what was happening is, like on Ethereum in particular, with this the ability for smart contracts to compose with each other or interact with each other. Very clever developers were able to borrow large amounts of money in a single transaction, blend against or borrow against this, adjust the kind of ratio of the price differential, and then pay it all back in one transactions, and then cause some very severe changes in the reported price. That kind of situation has caused some major loss in value. And then of course there's also the final version of exploits, which is where actually the node providers or the nodes themselves are front running the results. They're basically reading the results before they post it and sign off on it, trade against that before they post it, and then also just other vulnerabilities in terms of smart contract bugs.
So let me sort of like break those down a little bit from the point of view of like a developer or a user, right? So the first one, the data, a smart contract. Let's take a really simple example of like a bet, right? Where you and me are betting on the future price of Bitcoin. And now Bitcoin doesn't trade on Ethereum. It just trades on the Bitcoin network. Now, there's obviously wrapped Bitcoin, but let's pretend wrapped Bitcoin doesn't exist. And so let's say that our bet is actually just going to pay out in USDC. It's going to pay out in stable coins. Now, to do that, what we need to know is the price of Bitcoin at some future date. And so we need to pull that in. Now, your first class, you're saying that someone went, well, Binance trades Bitcoin against USDC, so we can just take a reliable source of data from Binance, and what we'll do is we'll report that source of data on Ledger. However, if the data source is wrong, then you end up with a problem. So let's take that first example. How does SupraOracles solve that issue?
Yeah, great question. So that is actually going to the root of what we do. Is we try to remove single points of failure in every instance, in every possible scenario. So what we do is we let me kind of posit this and phrase this a little bit differently about what is the price of Bitcoin in the world. So philosophically, the price of Bitcoin in this venue, this country, this jurisdiction, etc., this exchange is different. So there isn't actually a singular price of what Bitcoin is right now because it's globally distributed and trading at different venues, at different, jurisdictions and such. So the best that we can do as an industry, as far as I'm concerned, is we have to take into account, multiple exchanges and venues, take a look at their volume of like trade and give them some sort of representation of like a weighted median calculation. For lack of better words, it's what we do is we have a rating system that's fully transparent. Say, okay, for example, you mentioned Binance. Okay, Binance is one of the largest exchanges, has some of the most volume, etc. And this is, out of a rating system of 7, we'll give it a, maybe a 7. I have to take a look at the chart, and it differs on the pair based off of the liquidity and volume. So we have this as a framework. Then what we do is we dispatch multiple nodes to connect directly to the exchange WebSockets. Those nodes are randomized, and those nodes have to run around a consensus at that data source itself. Now, this is happening simultaneously across, let's just say, 21 different pairs, 21 different data sources for the pairs we care about.
Same pair, but 21 different exchanges.
Exactly.
So we're saying, okay, so there's 21 exchanges that have enough volume for us to consider that to be, and we believe the volume, right?
Yes,
Another problem in crypto.
It's a very good point.
Exchange volume real.
Right. Exactly.
So you got 21 sources where we go, we believe, and this is SupraOracle's own sort of like transparent rating system where you go, right, these are the sources we think are trustworthy enough, and collectively this is how we weight them together. So if I went to CoinMarketCap and rated and ranked by volume, those exchanges, the top 21 exchanges, are probably approximately what the sources are, and their Bitcoin USDC pair is what you're taking the data source of from their APIs, from their available APIs.
Right. So and I want to make this clear that we don't actually just use CoinMarketCap's information. It's one reference point, but it's we do a little bit deeper due diligence on that. But yeah, so imagine the case of Bitcoin, right? So we have a framework. Let's just say we have integrated with 21 reputable exchanges that we've done our homework on. We've created a rating system with many parameters in order to kind of give them some sort of rating. We dispatch random nodes, a set of them, run around a consensus at that data source, at each of them, in parallel. And what we'll do is we'll actually discover the median value, the middle value at the data source itself of those nodes. We'll aggregate those median values in a singular like block producer node who's aggregating them at the time. That node is also randomized through election, etc. And then we'll choose a middle value of the middle values, so to speak. But it's a little bit different, more like the weighted part of it is that, like I mentioned, Binance. So Binance might have a score of 7. We'll increase its frequency at which that data is used in our calculation, like 7x, for example. But we'll grab like the middle 20%. We'll do an additional kind of weighted average, and then that's our final result. Now, we are proving that this is a very good methodology. We're actually in the middle of publishing this, but we'll create charts where we track all the exchanges we have, and we have what we call our S value, our super value, and it's going to be in the middle of everything. So it's a very good representation of what is the price of Bitcoin at any given time. Now, what's great about this is this can refresh every 3 to 5 seconds. So we have a very good snapshot that has taken into account multiple data sources and parameters.
Okay, so like this is all fine from the point of view of now I have multiple data sources, but all of this like filtering and integrations and all that kind of stuff, is that then how's that then collated and pushed out onto the ledger? Is that pushed out through, is SupraOracles doing all of those calculations, all of those integration points, and then pushing out that aggregated data onto ledger?
Great. Yeah, good question. So we are doing our calculation and most of those work on our side, and then we have to deliver it to the destination chain. Now, in order for that chain to smart contracts on the chain to validate and use our data, they have to actually have some knowledge of our network topology, like which nodes or public addresses should we validate the signatures against, basically. And this is kind of one of our innovations as well, is that we have the ability to, we deliver data with this cryptographic signature. That cryptographic signature is verified against the smart contract that knows the knowledge of our network, basically, and can verify that. And when we submit this data, and by the way, what's interesting is anyone can submit the data, but they check the signature against their knowledge of our network topology. And if it verifies, then you can use the data. It's very secure. So you have the security guarantee of our network. But what's nice is anyone can submit it. Now, of course, when our network reshuffles periodically, we will also adjust the public addresses on the destination chain, so that next time you validate the data comes from us, you know that our network has had a majority agreement on this. So what's nice about this is anyone can submit the data, and it's verified with the verification process will give you the guarantee of our network itself, not just a small set of nodes.
So how's the data actually getting from off ledger to on ledger? Like, we've got the 21 data sources for this Bitcoin price. When you say anyone can submit it, what do you mean by that? Like, how is the data going from an off ledger state to an on ledger state?
Yeah. So we have, imagine actually our Oracle data is being added to our own internal blockchain. So we have the ability to to include it there. Now, for us to get it from our kind of independent network to your network, or any other network. How
does it get into your network?
Before
we go to the other network, how does it get into your network?
Sure. So these nodes that are randomized into different configurations at different exchanges and endpoints, they're running around a consensus themselves. They're sending it to a singular aggregator set of nodes, but let's just say a block producer. That block producer itself is the node that's accumulating and aggregating the values, organizing it, and then sending out that information with the proof of the different sets of nodes at the different data sources. So you have a singular block producer that includes the Oracle data in the block, and then that's how we get the block.
So all of these nodes. So to run a SupraOracle node, you have to be integrated into all of the data sources or a subset of the data sources.
Yeah. So there's a couple of models here. There's in our most, the low-hanging fruit is cryptocurrency prices. And in that kind of arena, and also like FX, there are multiple endpoints and multiple data sources. So every single node in our system has to be able to run and connect to any exchange that we care about, because it's a randomization process. So every 10 minutes, a different combination of nodes are sent out. And because of this randomization, you don't know who you're going to be paired up with, and it's very difficult to collude with Byzantine actors. Because you don't know at which given point you're going to be dispatched to which data source, you have to be prepared to be connected to any of them. So we're creating a very kind of plug and play, easy to use SDK, so that it basically handles all this. Now, I want to mention, a lot of these large exchanges, they don't change their WebSocket connections very often. So these updates are not as frequent as you might think. Maybe every couple of years or every 8 months or so. So we do have to push updates periodically. Nonetheless, once they're set for a while, because if these exchanges change too much of this information, all these other providers, even outside of Supra, other Oracles, other centralized systems, they all have to make updates. So it's very cumbersome for industry in general to make these changes often. So that's a nice thing, that these are not changing that frequently, actually.
Right. But theoretically, I suppose adding a new data sources can be a little bit of a pain in the ass.
It'll have to require some coordination. So we'll have a DAO or network governance that will have to be voting on these things, and they'll cryptographically approve it. And I think what we'll do is we'll have an opt-in system where nodes themselves, they can accept the DAO or majority kind of network governance decisions to upgrade and add new data sources as possible as it happens. But yeah, it'll be a little bit cumbersome, and we're going to have to rely on kind of the cryptographic majority decision of like network governance to, perhaps some nodes will just say, I will accept the majority agreement of the DAO or network governance, and I'll accept the update. Of course, the foundation itself will be, working with multiple audit firms, and we are already, and they will be part of that decision process as well.
So, I mean, like, for anyone who hasn't really spent much time in oracles, all of this is going to sound insane, right? Like, just the level of security that is necessary just to get off ledger data in a reliable way. And we've only dealt with one of the problem sets, right? So what we have here now is we have a network of nodes that is run, which is the SupraOracle network, which is its own blockchain. And presumably there's a bunch of staking and slashing to do with making sure that people are honest here. You mentioned a verifiable randomization function, which we won't jump into, but let's just assume is random and is fair. And that then as a result of that, each of the nodes that run in the network are integrating with these external data points, and then collectively are able to come to consensus as to what the actual answer is for, let's say, the price of Bitcoin right now. Now, that price of Bitcoin has been created, has reached consensus, and you guys have got a very fast consensus model, which is great. So sort of fast finality. Now there is an answer. Bitcoin's price right now is this against USDC. What happens then? How's that go from your network to someone else's network?
Right. So we do have built-in bridges. Now, bridges are, in short, what the nodes do. They have to run instance or light client on both our chain as well as the destination chain. So we have some visibility into it. Now, so we also will have smart contracts on the destination chain, right? So we can read inbound requests, and also, when we need to post the data, we can post it there. So, for example, if an inbound request comes in, our nodes will actually run a round of consensus to say, yes, this request is valid, it came in, and then we'll process it. Now, remember, just to be super clear here, it depends on the chain that we're integrating with, right? But let's suppose on Supra, we are running this consensus model in parallel every 3 to 5 seconds. We're running updates on the pairs we care about across multiple exchanges and endpoints, and we're able to achieve like our network-wide consensus on 3 to 5 seconds, okay, on the Oracle data. So this is like happening constantly. However, like, let me just use Ethereum as a classic example for now, just because we know that it's proof of work and it's slow finality. Right. And also it's expensive. So you can't post data to Ethereum every 3 to 5 seconds. Right. It's too expensive, and it just takes forever. Right. So instead, what we'll do is we have different data products that have different service level agreements, SLAs, where we will deliver the data according to whoever wants that cadence. So one might be every 10 minutes, one might be every 30 minutes, one might be every 0.5% deviation. So whereas it's being updated 3 to 5 seconds on Supra and it's on our chain, etc., we only have to deliver it based off of certain conditions. So this data product might be every 10 minutes, 15 minutes, 30 minutes, whatever it might be, or deviation in the price. Then we'll post it there. Every time you post it, especially on Ethereum, that's quite expensive, right? We're talking about $10. So this is too expensive to do every 3 to 5 seconds, right? So, and so every chain has a little bit different nuance as well as finality. So we posted it, but has it been finalized? Has it, you have to wait another 10, 15 minutes to get this kind of probabilistic guarantee that it is final. Our nodes on our side, when they agree it's final, they will run a round of consensus and then say it's final. So there's some nuance here for sure, but oracles with native bridges, remember our node network, it's a node network and it's randomization. Oracles with native bridges is actually a very powerful combination, because other than just getting Oracle data on chain, we can also take inbound information from this chain through our bridge, get that information to another chain. So we actually are trying to position ourselves once again as a middleware network to glue together multiple ecosystems and let arbitrary information between them.
So let's take that simple example of Ethereum, right? Now I have information on one chain that I need to get across to another chain. This is inherent sort of problem of cross-chain communication. So your node network, unless that they are running at least Ethereum clients, don't know what's happening on Ethereum. So how does your node network know what's happening on Ethereum, and how does the data actually get from your node network to Ethereum?
Right. So you need to have those nodes need to be running a light client or full node on Ethereum, or at the very,
Right.
very least, and we don't recommend this, but it is possible, plug into a service like Alchemy and Infura,
Right.
in
Okay.
a centralized service.
Yeah.
Now, we don't encourage that, but some nodes are going to do that. Um, Now, what this means is they have visibility of what's going on these other chains. They also are a full node
Mhm.
on Supra, so they know what's going on here as well. And there's a large set of nodes that have to come to an agreement. So it's not a small node set of nodes; it's a large set of nodes. At least 100 nodes. Let's put it that way for the bridge itself. Now, I want to make this
Mhm.
clear that the Oracle model, our nodes are not all necessarily going to be registered as a bridge node. So if I'm a node and I just want to be a regular consensus node on Supra, you don't have to necessarily be a consensus node on Ethereum. You don't have to play that
Mhm.
role of bridge on that. So that's a subset of nodes that have to participate on that. That is going to require
Mhm.
different staking. That's going to require different kind of parameters and joining procedure. Um, but I do want to. Since you asked a really good question, by the way, I want to say like these are you're throwing me some pretty decent hardballs, which is great because I love this stuff. And most people that interview us don't actually get this deep, so I'm actually enjoying this. This gives me an opportunity to share a little bit more about because we also have to think deeply about this stuff, right?
Right.
So the bridge security itself, you're bound by the set of
Mm.
nodes for the bridge security. So set of
Right.
in other oracles, you have a small set of nodes, and that's your oracle model. That's like the traditional old school model. You're bound by the
Right.
security guarantees for the small cluster of nodes, not a network. In the bridging, similarly, same thing. You're bound by security guarantee of the bridge nodes. So suppose you have 100 bridge nodes, and they all staked $100,000. That's $10
Right.
million. Okay, that's $10 million of bonded stake. The amount of value that's bridged between these networks should actually not exceed $10 million before it gets game theoretically unstable. Now, like if
Right.
you imagine these
But
nodes.
actually, it's actually less than that, right? If
Yes,
yours,
exactly.
if you're a BFT algorithm, you're actually your security is only a third of that,
Exactly. So
depending on what your malicious actor assumptions are. But yeah.
correct. So you want to keep that. And I was actually going to make that point. It's actually more like half of that value. The moment you go beyond
Right.
5 million, you start to enter this territory
Right.
of game theoretically unstable, right?
Right.
So that means like only so little value can go back and forth. So there needs to be some techniques and to kind of get beyond that. And we have a very interesting
Right.
technique. It does involve multi-party computation, threshold cryptography, kind of things that run our protocol in general, and another kind of
Right.
curveball, so to speak, that is not obvious, and we are going to be putting out that information in the months to come. But we have innovated the bridge model, so we can go way beyond. We can go way beyond that 5 million threshold that we just talked about. But let's talk about
That's really cool.
yeah, and I'm really excited about that. But let's talk about getting that data from our system to that system. Now, our bridge nodes, any of those nodes can post that data, and we'll create the racing condition. Whoever's the fastest to post the data, they get the fee. So it's actually going to, and the data is being delivered with this cryptographic signature of our network. So it doesn't matter who delivers it, but because the smart contract is going to check the data delivery plus this cryptographic
Right.
signature.
So because the smart contract on the receiving ledger Ethereum can check the quorum certificate of the data that was created on your network.
Correct.
So essentially, it can verify that the consensus was reached on the other network, and because signature verification is not expensive in gas fees, that's not a massively expensive thing to do. Okay.
Well, it's not cheap
That's
though.
like,
I want to mention it depends on the chain.
it's not cheap, but it's not as expensive as it should be. As in, it's one of the few things that is essentially subsidized on all networks because it's so important. Okay, so that's cool. So now we've got data that's come onto Ethereum.
Mm-hmm.
So who's paying? Who's sorry, go on.
Oh yeah, no. I think we just had a little bit of an internet hiccup. That's all. So I think you're asking about who's paying for the transaction fee,
Right.
and that's a very good question. So it's actually the node that submits the transaction. They have to pay that, right? right?
Right.
But they also collect the reward, which is more than their costs. And yeah, so any node can submit it. Actually, you don't even have to be necessarily a bridge node. You could just be an off-chain node that sees the request, answers as quickly as possible. That smart contract will still verify that signature against our network information and public address. So they know that still our network has achieved consensus on this information, because our network is still just pushing out this every 3 to 5 seconds, consensus. And then, but delivery, we don't post it to Ethereum or other chains that often because it's just way too expensive to do it that frequently.
Mm-hmm.
But when the time's up and it's time to deliver it, any node can race to do it and claim the reward. And actually what we do is those nodes have to have Ether, right? Because they have to pay
Right.
Ethereum. We will pay them out of Supra on our network. So we will pay them in our native token. So, and of course, since we have pricing data, we can do the conversion, and there's some other nuanced steps in between there. But since we're talking about pricing and payment models, I do want to share one very exciting thing that we're bringing to the table, which is we will allow projects that want our data on a very specific service level agreement, like cadence, like every 10 minutes, 20 minutes, whatever it might be. We'll allow them to have somewhat of a SaaS-like payment model. So they acquire Supra on our chain. They lock it up in a smart contract, like a domain-specific smart contract for our Oracle model. And then they're added to an access list on the Ethereum chain. So they get this data for free on the Ethereum side, like gasless. Right. And only those on the access list can have access to that. They have paid us for 6 months to a year on Supra side, though. And then we use that money to pay out the nodes that deliver the data, plus the other fees are, basically amortized and to all the Supra token holders in general. So this is a fee generating service. Yeah.
Okay, so you have this ability for people to essentially make sure that the data gets onto the ledger, and there's this payment through the SupraOracle token. This answers one of the questions that I sort of had, which is oracles often seem to be like they have the tragedy of the commons, right? Like, because once that data is on ledger, anyone can use it. But the question is who pays for that data to be on Ledger in the first place? Because once it's on Ledger, like if I'm building a DeFi app and I want the price of Bitcoin in USDC and someone else is paying for that, but it's being reported every 10 minutes to Ethereum, then I can just pull that data, right? There's no way of you going, no, only the people who are paying for it can get it, because that's the inherent issue of on-ledger data. How do you see that evolving in time? Mm-hmm. Like as it goes from one interested entity for paying for something to many interested entities for paying for that data?
Totally get it. Common scenario. Once again, only if you're deep into the field do you ask these types of questions. So I want to say, thank you for asking the hard questions. And when I mean that, so there's a couple of approaches here. One is, let's suppose this is a actual pull request. Like I want this information for myself and I paid for it up front. I don't want everyone else to benefit from this. Maybe I do, I don't care. Maybe I don't. We can also encrypt the data with your public key and post it encrypted, and only you can decrypt it and read it.
Right.
So that's one.
But a smart contract would not be able to read that, right?
No.
That's only me who's able to read that. So like as a smart contract, as far as I understand it, smart contracts do not have the ability to hold a secret and decrypt something that then can trigger an action in the smart contract without revealing that information to others.
Right. So there's another approach, which is also, as I mentioned, you get on the access list, and this becomes you can query the smart contract without gas. Otherwise, it's there, and you just have to pay the gas, but you'll pay for it. It'll cost more. Now, what's interesting is anyone on this access list, every time we posted it to the chain, anyone on the access list, they have shared the costs of verification and posting it. So it's cheaper, like if you have more people on it, it's cheaper for everyone. And also they have access to the data in the smart contract without having to pay gas. So yes, others could, but they're going to get the data and they're going to have to pay a bit more. It's actually going to be cheaper to just acquire Supra lock it up in a smart contract, and get onto our access list. It'll end up being cheaper this way. So sure, if you want it, if you want the values more frequently and at a cheaper rate, then you're better off actually just locking up some Supra, posting it on our chain, getting on the access list, and getting that data in a gasless manner on the destination chain. But yeah, so this is kind of one of the scenarios, where there are the free rider problem, so to speak. It is a little bit prevalent, but
Right.
if you just need it periodically, then that's fine. Just get it for free. But if you need it often and your
Sure.
product is based off of this, you're actually better off just getting on the access list.
Okay, so the second issue that you said was, and I think we can go through these quicker now that we have the basis of how the system works. The second issue you said was nodes collectively reporting the wrong information, but you weren't talking about malicious, right? You were just saying that the nodes were mistaken in this second event. So like, how can that come about, and how does SupraOracles prevent that?
So it's hard to differentiate malicious versus not. Now, if you
Faulty, sure.
if you posted clearly false data and you signed it, that is very easy to track who did what. What's harder to identify and to pinpoint the problem is when they delay the posting of their data. Delays of it, like it's hard to say like who's at fault here, etc. So if you have cryptographically signed false data, that's very easy to pinpoint who's done what wrong, and that is a slashing condition that's easy to pinpoint. But slowness is harder to do because network conditions, and there's a lot of like, hey, I just didn't get their information. It's like, it's hard to pinpoint what's going on here. So for liveness failures, we are not actually trying to penalize you for slashing. We are implementing a reliability score metric though. So if you do, as a node, are slow to respond in general, this may affect your reliability score over time. But also, how do we handle liveness failures? And in case nodes are trying to move slowly because they were trying to get their own trades in advance, whatever it might be, we have threshold cryptography. Or we use a threshold system. So we don't need all the nodes. We just need a threshold of them, any combination of the threshold. Let's suppose that there's 21 or 13 nodes per set. We only need 9 out of 13 to sign. So if the other 4 nodes are trying to collude or move slowly for whatever reason, if the other nodes are moving as fast as quickly, that does create the racing condition to just move fast and keep on going. So we don't rely on every single node. We rely on 2/3 plus 1 of the nodes per cluster. Now that represents one like set of nodes. What we call it clans. One clan at the data source. We're also utilizing multiple data sources. And then the final calculation, let's suppose that it is 21 data sources. We will use 15 of 21 data sources. And also each of the data sources themselves are 2/3 plus 1. So if there are slow nodes or offline nodes or malicious nodes, as long as those clans are majority honest, and then a secondary set of 15 of the larger set, 15 of 21, we will use that calculation to push it forward. So we just move forward with or without you, basically.
So the answer is basically more redundancy.
Yeah.
That means that mistakes can happen. Like data sources can be faulty or latent. And if everyone's using the same data source, it kind of doesn't matter. But like greater redundancy of both data sources and nodes will lead to less likely to have those issues. 100%. So the next one you talked about is the flash loan attack, right? Now, the flash loans attack's a really interesting one because a lot of these flash loans are actually using on-data ledger in the first place, right? Mm-hmm. Like, so let's take Uniswap. I now would go to the example that my bet for Bitcoin price is actually using the wrapped Bitcoin versus USDC pool on Uniswap. And now I'm using the Uniswap TWAP framework, time-weighted average price framework, to be able to decide whether or not on this day, at this time, approximate block time, is the price of Bitcoin above or below the bet threshold, right? Now, obviously with a flash loan attack, it's possible to do things like momentarily move the price of Bitcoin enough on Uniswap to affect the Oracle price that is being coming into my bet. So how does Supra help that situation?
Mm-hmm.
The flash loan attack, on ledger Oracle manipulation.
Correct. So that is when you use a constant function market maker, or the kind of so X times Y equals K model, which we were working with some research firms and academics to show that actually that is technically just an approximation of the value. It's actually not an accurate value representation of the price of Bitcoin at that moment.
Sure.
So we're working with other, groups and protocols.
I mean, that's de facto true. That's de facto true if your previous statement is also true, which is there isn't a price of Bitcoin. There's multiple prices of Bitcoin.
That's true.
So,
there is, right? Multiple prices of Bitcoin, correct. But can there be a more accurate automatic market maker utilizing Oracle data instead? Are there new types of DeFi primitives that can be created that mitigate slippage and impermanent loss, because we have better accurate pricing through kind of an Oracle network? So these are the kind of questions we're asking, and also prototyping and working with other DeFi protocols to explore. It does sound like you're going to get better pricing, less slippage, and less impermanent loss by leveraging an Oracle actually instead. But of course, if you use an Oracle like this, you have to make sure this Oracle is ultra secure and also fast, like refresh rates on a regular cadence that is makes sense. So it'll be very interesting to see. I mean, I actually think AMMs are a wonderful innovation. Don't get me wrong. I think it's cool. It's really cool. And they'll continue to exist 100%. But I also think that there's some sort of hybrid models or Oracle-based AMMs or et cetera. Those, I think they're going to come out and become very impactful as well, especially as we start to see there are some bizarre dynamics sometimes in terms of AMMs where actually it was more profitable to not have engaged in the AMM and provided liquidity. You should have just held the token itself. So it depends on the conditions of the market, bull market, bear market, et cetera. And I'm pretty sure that there will be some very powerful products that can be created by utilizing Oracle data. So that's to be determined. Now, I do want to make this clear that there are a couple of different types of Oracle models that are very important to share and that we also support. So we've been talking about the automatic model, like the algorithmic model, some of the multiple data sources, multiple nodes to multiple data sources, run consensus, aggregated, et cetera. That is a very fast model relatively to the other models. However, the long tail assets, like who won the football game, who was elected in this some random country in the world, we can enable we can enable the long tail of random questions that to be asked by leveraging just individuals or organizations. The question is posted, here's the prize, anyone can answer it, and then you introduce a challenge period. This is like the idea of what we call optimistic oracles. Okay, so optimistic oracles is like, okay, we can let anyone answer it, but we'll introduce a challenge period so that if someone wants to challenge it and say, hey, I'll double my stake, say you're wrong, and if no one challenges me thereafter after the challenge period or after it's been gone to arbitration, I can collect your stake or your bond, etc. This allows us to fill in the gaps of all the non-algorithmic points of information that we might want to need, that maybe cannot be solved through a algorithmic method. And then, of course, there's a single source model where it is like the NASDAQs of the world or other, single layer points of information where they are actually the authority of like the equity prices, because that's where it comes from. Those types of models, while it's very difficult for us to make that algorithmic necessarily, those nodes can be a full node. They can be listed in smart contracts and they can cryptographically sign the information. Of course, once again, I do want to always caution that is, still technically an essential point of failure. So use it with care. Meaning, if that API or private key gets in the wrong hands and they sign the wrong thing, and you push this information into smart contracts, they might not know the difference. Nonetheless, there are the algorithm model, which I mentioned with the multiple nodes, the optimistic oracle model, which is anyone can come in and answer it and introduce a challenge period. Introducing the challenge period, however, increases latency to hours or days. Right? Algorithmic is 3 to 5 second finality. Right. Challenge period says, hey, look, anyone can challenge me for 3 to 5 days, whatever it might, or 3 to 6 hours, whatever it might be. And single source is just, single point of failure possible. Yeah, so different models.
Right.
So yeah.
Sounds similar to sort of the UMA approach where you have like this, what is the result, and then a period where you can challenge the result, and sort of like a ever increasing staking game,
right,
that brings in more people.
Right. Yeah. No. It's actually
very interesting.
Yeah. I got to say about that. Our internal research team have been talking about optimistic oracles for like a year. We just never published any information about it. I did hear about UMA talk about optimistic oracles. I was like, oh, it's the same idea. UMA can't do the algorithmic model though. So
no, and like UMA is
yeah.
designed for something else anyway.
Exactly.
Like it's they're not designed for an Oracle system. They're specifically designed for building options, which is a subset, right?
Sure.
But yeah, I think it's a very clever idea. I don't think there's anything wrong with one thing being like another, and often things end up being created at the same time.
Exactly.
And that's often a indication that everyone's going in the right direction. So yeah, it's not me. It's not me trying to go, oh, you guys copied these guys. It's it's interesting that those are the same ideas coming out.
Exactly. It's assuring.
Awesome. So, Josh, it's been such a pleasure talking with you. I could talk with you for another couple of hours, but we really do need to wrap it up and let you get on with your day. But it's been such a wonderful pleasure. If people want to find out more about SupraOracles, want to get involved in the community, want to find out what's happening next, where should they go, and how do you want people to engage?
Yeah, certainly. So SupraOracles.com. Our Twitter handle is simply SupraOracles. Reach out to us, find our Discord, jump in there. We'd love to talk to DeFi founders, protocol designers, engineers, etc. If anyone cares about securing the Oracle layer, like the Oracle layer sits on top of the kind of blockchain layer. Imagine you got the blockchain, a layer above that is the Oracle layer. It has to be a very protective layer. It has to bring the security guarantees of the underlying blockchain because it interacts with the real world. And if anyone's passionate about that and is really interested in getting involved, always reach out to us. We're very open. We are hiring as well. And we hope to, once again, play this middleware solution, connecting multiple ecosystems together and helping to bring forth this multi-chain vision. So yeah, reach out anytime. We're very open to have discussions.
Awesome. Josh, thank you so much.
Thank you too.